Hello everyone, my name is Mengyuan Li and today I'm going to do a presentation of my final project which is called PT and UBST on testing a scientific calculator. First, I want to introduce some motivation and basic introduction. Normally, in many software systems, when you test it using whatever testing techniques, the test cases or input possibilities are finite. However, when you test a calculator, for instance, theoretically speaking, there are infinite input data possibilities and you cannot test every one of them. So this makes testing become an interesting thing and motivate to do some research on this. For the introduction in this project, I'm going to test a scientific calculator app with two different strategies, which are partition testing and usage-based testing with an operational profile. Through the entire testing activities, I would like to test if all the functions of the scientific calculator can operate correctly without any calculation mistakes or crash problems. Once more, I will compare the difference between the two strategies in testing efficiency and the testing results. Besides, I'm going to find whether the two strategies can ensure the reliability of this app, so I can detect some defects in this app and fix it to improve the quality of this app. Next, I want to briefly introduce the app that I'm going to test. I'm going to test a scientific calculator app developed by Android Studio in this project. Here is the screenshot of this app. As you can see, this app can do calculations that contains integers, decimals, trigonometric function, and parallelism with four operators, which are plus, minus, multiply, and divide. The main problem that I'm going to investigate is to test all the functions of this scientific calculator app and whether there are some kind of crash problems. First, I will do partition test. Firstly, for an expression, there are two kinds of input button, which are number button, 1 to 9, and point, sine, cosine, and tangent, and the operator button, plus, minus, multiply, and divide. So actually there are thousands of combinations of expression and I cannot test every one of them. So I will do the partition test for this app. Secondly, for basic expression, the normal form would be number 1 operator number 2. For instance, sine 1 plus 2 or 3 multiple 4. Number 1 and number 2 both have 4 types, which are integer, decimal, trigonometric, and parallelism. And the operator has 2 types too, which are plus, minus, multiply, and divide. So basically there are 64 kinds of partitions which are mutually exclusive and exhaustively collected. Here are some results and analysis. From the results, I can conclude that in the 55 test cases, the operator works well and the app shows the correct calculation results without crash. And in the remaining 19 test cases, the app shows the incorrect calculation results or the app just crashes. So I can get the failure rate, which is 29.6875%, and the success rate is 60.3125%. For a calculator app, this result is totally unacceptable because when people use a calculator, they always want to get the correct answer without any crash problems, which destroy the user experience severely. What's more, maybe 64 test cases are a little bit redundant and cost a huge time and resource to test, because for every test case, I need to do the execution maybe 3 to 4 times to make sure the accuracy of the test result. So the total workload is a little bit heavy. Then here is the detailed table for the detected defect. From the table above, I can find that the crash rate of defect is 84.21% and the calculation mistakes rate is 15.79%. So I can conclude that crash problems occur more frequently than calculation mistakes, so the crash problem is more urgent issue for me to fix than calculation mistake. mistake problems. Next, I will take a look into these defects. First, for those crashed test cases, when I compare them with each other, I find that they have a common characteristic. Their form are the same, whatever kind of number one, whatever kind of operator. So this means for this situation that a trigonomic number after an operator, there must be some problems in the corresponding code part of the project. The problem must occur during the conversion of infix expression to suffix expression. Later on, I will examine this part carefully to find out what the specific problem is. Second, for those three calculation mistake test cases, they have common characteristics too. Their results are very close to the correct results. The error is close to zero. Here is the detailed table for these three calculation mistake test cases. So I think this calculation mistake may not originate from the calculation process, because if it originated from calculation process, then the app will show the incorrect results rather than results which are so close to the correct results. The mistake must originate from the display of results or the form transformation of number from string to double to string. Later on, I will examine this part of code carefully too to find out what the specific problem is. Next, I would like to use UBST to test my app. From the discussion above, we know that the workload of partition testing is a little bit heavy, and it can't test the function and reliability of the calculator app effectively. Besides, different users may have different usage habits. For instance, for pupil users, they basically only need to use the functions of plus, minus, multiple divided with integers, and junior school students may need the function of them with integers, decimals, and parentheses. So UBST may be a better idea. First, I would like to collect the data I need from a social survey and expert opinions to know the usage frequency of different parts of this calculator app. For the users of this system, it's more likely from the school. I would do the survey in a high school and elementary school. Besides, I would ask for the suggestions of experts, for they have experience for testing this kind of app. Next, I would like to build my own operational profile based on the data that I have collected and tested. So you can see the OP here. And then I would like to introduce some result and analysis. For the pupil testing team, there are 15 test cases and which only contain integers. Here is the result table. From the results, I can know that this app can do plus, minus, multiple divide calculation without any mistakes. The failure rate is 0, which means that this app is ready to deliver for pupil users. And for junior high school students testing team, there are 30 test cases which contains integer, decimal, and parentheses. The result table is shown as below. From the table, we can know the failure rate of this team is 6.67%. Although there are not any crash problems, calculation mistakes is also a significant problem to solve. And then for senior high school students testing team, there are 30 test cases too, which contain integer, decimal, trigonometric function, and parentheses. From the table, I can conclude that the failure rate is 80%. Besides, there are 6 crash problems in this team, and a crash problem is a kind of severe quality problem, which is totally unacceptable and destroy the usage experience. Then I would like to introduce the normal individual user testing team. For this team, there are 5 test cases which contain integer and decimal, and they all operate well, very well. And for company user testing team, there are 20 test cases and contain integer, decimal, and parentheses. But there are also testing cases which give the wrong results, and the failure rate is 5%. Later on, I would compare these two strategies. For the two strategies in this project, they both have their advantages and disadvantages. For partition test, I would say it is more complete and cogent than UBST because it tests all the possibilities of combination of input button. However, the workload of this strategy would be a little bit heavy and less effective than UBST. There are two reasons why I think so. First, in the UBST process, I grouped the testing team into 4 teams and aimed at different kinds of users, so the testing is not for all users, which means that the app can be delivered to the specific market in advance for some specific teams which don't have any problems. Based on this, the company will gain more business benefits due to the early launch. Second, like I did in this project, it is more convenient and effective to do the maintenance work if I group the testing team into 4 teams for 4 markets as well. After the app is delivered to the market, different testing team can be in charge of different markets. Finally, I would give a summary of this project. In this project, I test a scientific calculator app developed by Android Studio with two strategies, PT and UBST. This app can do calculations, plus, minus, multiple divide with integers, decimals, trigonometric functions, and parameters. First, I do some analysis before the execution activities. For PT, I analyze the process of calculation and how to generate test cases which are mutually exclusive and exhaustively collective. For UBST, I do some social survey to collect the usage information I need. Based on this preparation work, I build my own partition table and my own operational profile. Later on, I execute those test cases on the app. With two strategies, I find some crash and calculation mistake problems in both of them. After that, I do some follow-up activities which are examining the corresponding code part of those problems. Then I can rewrite the code or optimize the code to improve its performance and reliability. Finally, I compared the advantages and disadvantages of these two strategies. PT is more complete and cogent than UBST, and UBST is more effective than PT. So that's all for my project. Thanks for watching.